The first day I started lecture, I said, well, function output is a function of inputs. And I said, well, think of it this way. Cookie is a function of a bunch of things. Sugar, flour, water. Someone said milk, eggs, etc. I've got way too many inputs. One output, which is y, in this class, we're just going to be happy with one input. So instead of having all of those, our standard notation y equals f of x. Is it fair to say that y is related to x through f? Yes. Is it fair to say a cookie is somehow related to sugar? Unless you're a diabetic. Cookie is somehow related to flour? Yes. So y is related to x through f. F is what is describing the relationship. Is Cookie having a good relationship with all of those? Bad relationship, exponential, linear, logarithmic. So F explains the nature of relationship. By nature, I mean to say linear, exponential, logarithmic, etc. What is the keyword of relationship? Relation. Have we heard this word before in algebra? Relation. Kevin? Okay, do you want to explain? No?
No, I don't know.
Don't remember? Anyone else? No? Okay. We have y, we have x, they are related. Relation is something that we use in set theory. You've got a bunch of elements here, a bunch of elements there. You make a connection, that's a relation. For instance, that's good. So y is cookie, taco, soda. X, sugar, liquid, spicy, solid, semi-solid. Good. I want to make a connection between the two. Can I erase that? Is anything coming back to you from algebra or no? It's coming back to you. Okay. Why? If I ask you to make a connection between sugar and something on this side, what are the elements that you would connect to from sugar to this side? Evan?
Cookie and soda.
Cookie and soda, assuming, it's not diet. Good. Liquid and what is it? What two things should you connect? One in X and one in Y. Liquid to soda, okay. Start right soda there. Spicy. You was doing something more spicy.
Taco.
Obviously, taco. Solid. I mean, if you're going to make a liquid cookie, you shouldn't bake. Solid, semi-solid, kind of solid, taco. It's got some air in it. Okay. Set one, set two, connectivity. So whatever that explains this connection, those lines would be a function. Good. Can you give me an equation that would actually explain that picture to me? Is it possible that you come up with an equation so when you plug in sugar, you get cookie soda time? Possible? No? Do you follow my question? Can you come up with an equation y equals something in terms of x? So when you plug in sugar, value of y must be cookie. Doable, not doable? Just say that, doable or not doable? Vincent, you can't do it. How? I want an equation. Okay. Is it possible? I can't. So in this case, no equation would actually explain this connection right there. You can't put it as a function, which is why we leave it as relation. There are ways to do this beyond the scope of this class. Same example. But with numbers, I am going to use 1, 2, 8, 2, 4, 16. Good. Then two functions perhaps could give this relationship or explain this relationship. So I've got a bunch of x values, bunch of y values. I want you to give me an equation that would describe the connection between x and y, that sort of relation. So
2x equals y.
okay, 2x equals y. Do we agree with Sophie?
Yes.
Good. Plug in x is equal to 1, y is 2, x is 2, y is 4, x is 8, y is 16. Easy, piece of cake. Correct? So, when you have to write equations, you need to have numbers. Period. Math deals with numbers. That said, what is the difference in terms of the relation that you see here and there, aside from one being, something that contains numbers, the other doesn't contain numbers? What sort of relationship do you see here when you compare it to that one?
The second one only has one input for one output, and the other one has multiple outputs.
Did we hear what you said? let's start with simple terms. Nicer, right?
1x will always equal 1.
Straight lines. But I mean, I drew it this way, of course. Only drawn in a different manner. If you look at this one, messy, one x value is mapping to a bunch of y values. So if we want to deal with functions easily, we would like to have a scenario of this sort. Okay? There is a name for this. Brock sort of gave us a hint. Do we remember from algebra? If not, I'll repeat what Brock said, and hopefully it comes back to you. Brock said one x value will give only one y value. Nathan,
The input output function.
a function has input output. That's
1-to-1.
what's your name?
Chrissy.
Chrissy, finally you spoke. 1, 2, 1. One x value results in one y value. This is 1, 2, 1. One-to-one functions are easy to deal with, and we like functions to be one-to-one. Here's a question. All the examples that we did in chapter 1, are those functions one-to-one?
Yes.
Yes. Every single graph that you sketched in the previous lectures, straight line, one-to-one. One x value will result in one y value. There is a way to determine whether a function is one-to-one or not. Do you remember?
Or it could be like a parabola is not 1-to-1.
Okay. What is the easier way to?
It's an exponential function.
Okay.
Test.
What did you say?
Straight line test.
Straight line test. Finally, you spoke too. What's your name?
Brianna.
Brianna? Brianna. Okay, Brianna says straight line test. Well, a straight line could be of multiple types.
Well, like if it hits 2 spots,
Very good. 2 spots, and you went like this. What type of line is this?
a Y, like a Y.
Linear.
Horizontal.
In horizontal. Okay. Sophie started with the parabola, so I'm just going to go with that. Parabola, yes. Draw a line. It is touching 2 points. If you have a graph of that sort, then your function is not one-to-one. Good? Because one different x values, say I have x1, x2, both result in the same y basket. I've erased it, but over here we had sugar and something else going to a cookie, right? 2 inputs resulting in the same output. Horizontal line test. Do we like how? No? That's fine. You do like how? Oh, you have a question, go ahead.
Would it still be a function though?
It is still a function, it's just not one-to-one. I'm going to draw the other case in a second where things aren't a function. Easier way to remember, hopefully you like how, lettuce, tomato, salmon, HLT. What is your name?
Corey?
Corey? Okay, Corey's question, well, would it still be a function? Rather, is a function. if I tilt it sideways, I'd end up getting this. Yes, I have a single x value, say here, I'll let x1. One's going up there, one's going down there. Is it functioning properly? Easier way to remember. There is a switch in your living room and controls the light. If you turn it on, what should happen to the light? If you flick that switch, what should happen to the light? It turns on. Now, would you say the switch is functioning properly? Great. You flick that switch, and all of a sudden, it turns on the light, and the garage door opens. Is it functioning properly? Not a function. Easy way to remember. So, one input can only have one output in order for a function to be, for an equation to be a function. That is not a function. What type of line did I use? Vertical line. Naturally, this is vertical line test. We don't abort mission if something's not function. This is a curve. There are ways to make a function that is not one-to-one and convert it to a one-to-one function. We can take a function, we can take a curve and convert it to a function beyond the scope of this class. One other important thing that you've got to know when you're dealing with functions is domain and range. Do we know what domain is?
Your highest and lowest x.
Highest and lowest x values. That is an interesting way of putting it, Gio. Haven't heard that. Okay. Highest and lowest values, do you mean to say just the highest, just the lowest?
Well, yeah, like the highest it can't be on the graph.
Or the x value? Okay, Nathan, help
Is it
you out.
negative infinity, positive infinity? Or
Come
is it-
again?
Is it negative infinity, positive infinity?
Should it always be negative infinity to positive infinity?
But usually isn't it?
So that was my question to Gio. Gio said, oh, the largest x value, smallest x value. Well, are they just single values? True. Any x value?
Well, it kind of tells you more of the constraints. So if like the x value stopped at zero, well, started at 0 and went to like positive infinity, you could kind of put that constraint to show like where the either parabola or line is going. And that would be, you define that in the domain. So
Okay.
like 0, comma.
Okay.
Yeah.
Hannah, interesting word, fancy word actually, a constraint, a domain. So Gio said, well, here, smaller value 0, bigger value infinity. Well, we're not simply referring to the start and the end, rather we're stating everything that is in between the start and the end. So one case, for instance, here is what Nathan suggested, negative infinity to positive infinity. Needn't be negative infinity to positive infinity always. This example. Set of all possible x values. What is the range? Possible y values for every value of x in the domain. I'll do a couple of examples of finding domain and range, and then we can move on from it. If you have any questions, talk to me.